All right. So in this problem, I don't actually know what I'm going to try and use before I start. So I'll just walk you through how I would do this and explain my thinking as much as I can, keeping in mind that I might use law of cosines or I might use law of sines, whichever one is convenient. If I have a choice between the two, I would go with the law of cosines because when I use the inverse sine function, that's what allows there to be two different angles that might work for like if I'm trying to find an angle using the law of sines. If I'm trying to find an angle using the law of cosines, there is no ambiguity. There's only one answer that will come out, and there's no guesswork in it at all. You don't have to check an extra angle. So I prefer using law of cosines if I can. If I can't, then I'll have to use law of sines, and we'll see where it goes from there. So on this problem, I know that alpha and A have to be opposites of each other. So this, I'm going to label it alpha, but I'm also going to write the 10 degrees. And this is 3, but I'm also going to label it as A, so I can use it later on. I think it's good to label everything anyway. That way when you're trying to use any of the laws, you can just look at your picture and see what is what without having to refer back to this stuff. So there we go. Any side, I could pick any side for B, but that, if I pick this side for B, then that dictates where my beta goes. And I'm just going to do that. B is 4, so this will be 4. Then beta will be that corner across, and then this then has to be gamma, and we'll call this C. Now, what would I use? Immediately, I just start looking and seeing what I have. Remember, the law of sines is dealing with the sine of an angle and the side opposite. So if I have one of these pairs and I have one of the other ones, I might use the law of sines because I have 3 out of the 4. So let's see what I have. Well, I have A and alpha. That's good. And I have B. So I need to find beta. If I'm using the law of sines, that would say I have to find beta first. There's really no way, with the law of sines, there's really no way to find out what gamma or what C is. So I have that. That's something there. And then I would also, I don't really want to use the law of sines to find an angle, just because it gives me those two cases. But so I'm going to try and see what I can do to solve for or using the law of cosines. Now the law of cosines, it's like C or A equals whatever. Well, hopefully you know it, but really what I'm looking for are just things that I need to solve for. I need to solve for gamma and C and beta. So those are angles. Suppose I wanted to solve for beta using the law of cosines, because I don't really want to use the law of sines. It gives me those two cases. So I would say, okay, well, I'd have to use b squared equals a squared plus c squared minus 2ac cosine of beta. And then I'd get this all by itself. However, I don't have c, so this poses a problem. So I can't use this version of law of cosines. I can't do that. I want to find beta, but I can't because I don't have that c value. And if I tried to solve for the c value using the law of cosines, it would be a c squared there and gamma there. And then I don't even know both of them. I don't know both of those. So there are two unknowns there, and I want to have only one unknown out of my 4. Sorry. So I'm going to have to use the law of sines, and I'm going to have to deal with that case where there might be 2 betas. So let's see what happens. I guess I'll use, I have to use sine alpha over A. And then I can't use it with gamma and C. I already think I said that. Hopefully I said that. So I must use it with sine of beta over 4. Now really, if you notice, I just went through all of those cases. Normally, if I'm solving the problem on my own, I just do that in my head. But that's the way you should be thinking. Like, what can I use? I mean, write out or have in your head the law of sines, and see if you can fill in 3 out of the 4 missing pieces, or try law of cosines and see if you can fill out the proper things. And if you can't use it. It's really just trying, because each of the triangles are different. And I don't think it's really relevant or useful if you classify each case. I'd rather just have you understand what the formula is and then do a little bit of thinking. Kind of like guess and check, except for you're not really guessing at an answer, you're just guessing at which formula to use, which I don't think is that bad. So I'll multiply both sides by 4. So I have 4 sine 10 degrees over 3, and that's going to give me my sine of beta, and I'll get that as a decimal. So I get sine of beta equals 0.231530903555907. I would just write it all down just to be safe. It didn't take that long to write it all down, but I just keep it in my calculator and I don't round it all. So if I need to use this value again or the other one, actually no, I need to do inverse sine now. So I'll do inverse sine to actually get my angle, and I get beta is 13.387219 something degrees. Now normally I wouldn't write that many decimal places, but I might have to use this again. So it's good to write out more decimal places. That way I don't have any rounding errors. Alright, so I have my beta. But from the notes, we can get beta number 2 anytime you're using, right? This is one of the things. Anytime we're using a side, and an angle, we could possibly have 2 cases for beta. So I got to check. And beta 2 would just be 180 minus beta 1. So I'll do that. And that's going to give me 166.6127.807. I'm just writing down a lot of decimal places. Those are degrees. And then I'm going to check both of them. So what do I mean by checking? Let's see. Checking beta 2, if I check that, if I put in beta 2 right there, that's 166 degrees. 166 plus 10 is 176 degrees. And that would make alpha, if I subtract that from 180. That would give me 3 something degrees. 3 degrees. So here, whoops. Here would be 3 point... that would be 3.3 blah 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 degrees, and I guess I could do that. I mean, I don't see any problems just yet. Actually, well, maybe I don't. I don't know. Well, let's see. That's with beta 2, so that's actually gamma 2. So maybe I should circle this and say this is gamma 2. How do I know it's gamma 2? It's because I used beta 2 to get that, and then I could just continue solving the rest. What would be gamma 1? Well, I could do the same thing. Add 13 to 10 and then subtract from 180. That would be 156. So gamma 2, maybe I'll write it down here. 156 degrees if I added those up and subtracted from 180. So gamma 1 is 156.612781 degrees. I'm writing down that many decimal places because I still need to find a C value. Let's write gamma 2. That was 3.3, was that an 8? I think it's an 8. 38721. This is why I would prefer to use the law of cosines, but if there were 2 triangles, I mean here, definitely 2 triangles work out, so I'll have 2 sets of answers. The law of cosines wouldn't work. It'll just turn out that way. And so I use these values to find my C, and I use these values to find my C2. And I just go on from there. I'm just going to write down, that is using, well, I suppose I could use the law of sines again, right? I mean, I could use the law of cosines, but the law of sines seems like less work to me. I mean, we already did the added work by finding the beta 2 and gamma 2, so might as well just use the simpler method, which is law of sines, unless you get, well, I'm rambling. So we have gamma, so we can do gamma over C, because we don't know C. We have A, or alpha, and A, so I'd set that up and find C1. So using those two things, what would I write? I'd write sine of A, or alpha, which was 10, over 3, yes, over 3 equals sine of gamma 1, which was 156.612781. It's a good thing I wrote down all those decimal places, over C, and then solve for C. So my C value, C is, or this is C1, is 6.86. And here I'm rounding because I know I'm not going to have to find C again or I'm not going to have to use that C value because that's the last thing I had to solve for my first set. And then I'll do the same thing, except for I'll use gamma 2, right, to find the different C value. So sine of 10 over 3 equals sine of my different gamma, which is 3.38721, divided by C, and then I'll solve for that. That would be my C2 value. And then my C2 value is 1.02, and again I'm rounding there because I know I'm not going to have to use that C value again. So here, okay, how do you know when to use the law of sines or the law of cosines? You really don't until you try it, so you try something out. That's what I usually do in my head, or I usually just talk about it when I make these videos. So you just gotta try. I try to avoid using the law of sines if I can, because there's no ambiguity. It just happens that if I can't use the law of cosines, I have to use the law of sines. And if I'm using the law of sines and I get two sides and an angle, and I'm using it to solve for another angle, that's when I have to check to see if I have a beta 2. And in this case, I did have a beta 2, and there was a special or another set of answers that I could get. So this could have made two different triangles. One where gamma is really small, acute, and one where gamma went way out here, and it was really wide. This was a long video. I mean, the answer to your question is you just have to try. Try both of them. See what situations you have. And that's it.